So in this lesson, we'll be going through an arithmetic series, and we'll be learning how to calculate the sum of an arithmetic series and compile the 3 questions. With the last question is really uber important, and really need to get the grasp of it and really pay attention to that. And this is really a schematic of how examiners would ask you questions relating to arithmetic series. So suppose you're given the arithmetic series of 8, 12, 16, 20, and 225 terms. So it means that really, whenever they refer to terms, they're referring to n. We have to calculate the sum of the arithmetic series. So this series is 8, 12, 16, 20, and it continues up until 25 terms. So really, the properties of an arithmetic series are similar to the ones of an arithmetic sequence. So the difference between the arithmetic sequence and the series has really, it adds up, right? Really, or subtracts to a certain value. But a sequence really is just a different sequence with different semicolons in between. So really, the easiest way to see that something is a series or a sequence, it's whether there's a plus or minus in between the terms. And we're still dealing with an arithmetic, meaning that the general term is a n minus 1 times d, and really our a is still our first term, and our d is our common difference. So those are the properties that you need to know, and also you need to know the sum formula for an arithmetic series, which is given by sum n is equal to the number of terms divided by 2, open bracket, 2 times a plus n minus 1 times the common difference. Or alternatively, we can use the sum is equal to n over 2, open brackets, the first term plus the last term, depending on what you're given. You usually use this equation when you have the last term of the sequence, really. So really, those are the 3 main formulas you'll be using. So let's answer this question. We're asked to determine the sum of this arithmetic sequence. How do we determine the sum of an arithmetic sequence? Firstly, we need to determine what our a value is, what our d value is, and what our n value is. So in this series, we know that a is the first term, which is given as 8. We know that n is equal to 25. They're telling us that it goes up to 25 terms. And d, we don't know what that is, but we can find what the constant difference is by using the lines of differences, which will be 8 plus 16 plus 20 continues. So we're going to say t2 minus t1, which will be 12 minus 8, which will be 4, 16 minus 12, which will be 4, 20 minus 16, which will be 4, which means our d value we just calculated will be equal to 4. So we have n, we have our first term, we have n, and we have our constant difference. So we can substitute and calculate the sum of 25 terms. So the sum of 25 terms will be equal to our n value, 25, divided by 2, open brackets, 2 times a, the first term, which is 8, plus n is 25, minus 1 times a common difference, which is 4, then we close our brackets. And then we should calculate what the sum of 25 terms is. So in your calculator, you can go and say 25 divided by 2, open brackets, 2 times 8, plus 25 minus 1, close bracket, times 4, then you close your bracket again, and then you'll find that the sum of 25 terms is equal to 1,400. And that way we would have answered our first question. If we move to the next question, this question, we're given that the arithmetic sequence is given as 13, 6, minus 1, minus, and then we're given that minus 106, meaning that minus 106, the last term. They're asking how many terms there are in the series and calculate the sum of the arithmetic series. So, our first question, given the 13 plus 6 minus 1 minus, it continues, and then really the last term is negative 106. And we're asked how many terms is are in the series. So to determine how many terms are in the series, you just need to locate what term number will this value be, because it's the last term. What term number will that be, using the arithmetic series. So what we need to do is determine what our A is and our D is, and we're going to use it in our formula for the arithmetic series. Tn is equals to A plus n minus 1, and we'll use this to calculate our n. So let's calculate 6 minus 13. 6 minus 13 is 7, and then minus 1. 6 minus 13 is minus 7, minus 1 minus 6, it's minus 7. So we can see that our first term, A, is equal to 13, and our constant difference is minus 7. So therefore we can write our general term as our A value is 13 plus n minus 1 times our common difference, which is equal to 13. Then we multiply in this bracket to give us negative 7n plus 7. Therefore, our general term Tn is equal to 13 plus 7 will give us 20 minus 7n. So once it's in this format, we'll be able to determine how many terms there are in the sequence by substituting our last term, negative 106. So let's quickly do that. We're going to substitute negative 106 into our formula, is equals to 20 minus 7n. And what we do, we can take 7n to the left hand side to be positive. Then we say 20, take minus 106 to become positive 106. So we need to determine what 7n is. So we just say 20 plus 106. We'll get that 7n equals to 126. So we divide both sides really by 7. If we say 126 divided by 7, to get the answer of 18. So there are 18 terms in the sequence, because if you substitute the value of 18 really back into this Tn, you get that where there's n, you get that Tn will be equal to negative 106. And let's go to the second question. So in the second question, they're asking us to calculate the sum of the sequence. So they're asking us to calculate the sum of the sequence, and to calculate the sum, what do we have? We have our A value, which is 13. We have our D value, and we know how many terms there are in the sequence, which is 18. So you can use really either formula Sn n over 2. You can use this formula of the first term plus the last term, because really we know what the last term of the sequence is. So you can say the sum of 18 terms is equal to 18 over 2. First term of the sequence, A, is 13, plus the last term is negative 106. S of 18 is equal to, if you pass this into the calculator, you get that the sum of all these terms will be negative 836, 837. So if you want to, we can also use the alternative really sum formula to calculate what the sum is. You can go on and substitute to this formula. The sum of 18 terms is equals to 18 terms over 2 times the a value, which is 13, plus n, which is 18, minus 1, times the common difference of negative 7. And then really we calculate that. We can plug that into the calculator. 18 over 2, open brackets, 2 times 13, it's 18, minus 1, times the common difference, which is negative 7. And then you see that we get negative 837, which really is consistent with either formula you use to calculate the sum. And we would have answered both questions. So we can move on to the next question, which really is the highlight of this lesson. The next question is the highlight of this question, which is, we can label this really a C. So we're given this arithmetic sequence, and you asked to calculate the sum of all natural numbers from 5 to 100 that are not divisible by 5. So really the formula that you need to know really to take you out of any mathematical misery is that the sum of all natural numbers is equals to the sum of all natural numbers divisible by 5 plus the sum of all natural numbers not divisible by 5. So really what you need to know with this type of question, calculating the sum of all the numbers that are the sum of all natural numbers from 5 to that are not divisible. So what we're looking for, we're looking for the sum of all numbers that are not divisible by 5. So we need to calculate really what the sum of all natural numbers are and the sum of all the natural numbers that are divisible by 5. Right? So how do we do that? How do you calculate the sum of all the natural numbers divisible by 5? So the sum of natural numbers divisible by 5 really in this arithmetic series, right, is we have to look at the series as counting numbers, meaning that we'll say 5, 6, 7, 8, and this continues up until 100 because natural numbers are not counting numbers. So, and another pattern that we have to look at separately is the number pattern, where sum of all natural numbers divisible by 5. So numbers divisible by 5, this pattern will be 5, 10, 15, 20, and it continues up until 100. So we need to find the sum of the series and the sum of that series. So really, let's really get onto it and calculate the sum. To calculate the sum here, we need to find firstly what our a value is, and you can see that our a value is equals to 5. We need to calculate what our d value is equals to, and we have to calculate what our n value is equals to. So we can quickly calculate that. D value will be 5 minus 6 minus 1. 6 minus 5 is 1, 7 minus 6 is 1, and 8 minus 7 is 1. So we can see that the d value is 1. So therefore, our Tn is equals to a n minus 1 times d. That will be Tn is equals to our a value, it's 5, plus n minus 1 times d, which is 1. which then can be written as Tn is equals to 5 plus n minus 1. And really we can rewrite this as Tn is equals to n plus 4, because 5 minus 1 is 4. And remember, we're calculating n, so to calculate n we need to find what this last term is, and we just substitute 100 equals to n plus 4. Therefore n will be equals to 100 minus 4, means n will be 96. So once we've done with that, we're not done. We need to calculate the sum, remember, of this sum of all the natural numbers, so the sum of the series. So to calculate the sum of the series, remember we calculated that our n is 96, and we also know that really the last term is 100. You can say the sum of 96 terms is equals to, let me bring this a little bit lower, the sum of 96 terms is equals to n, which is 96, divided by 2, open bracket, our first term, which is 5, plus the last term, which is 100. And we need to find what the sum of 96 terms is equals to. So we just go to a calculator and say 96 divided by 2, open bracket, 5 plus 100, and determine what the answer is 5,040. So now we found the first part of it. So we found what the sum of all the natural numbers are. So we almost at our answer, because we found really one of the tricky parts. So once we know the sum of all the natural numbers, we just also need to calculate what the sum of all natural numbers that are divisible by 5, right? So we do the same thing for the red really sequence. What we're going to do, let's just really take this answer of S is equals to the sum of 96, 5,040. We'll be using that because it's the answer for there. So now we can go ahead really and make room to calculate the rest of the values, or to answer the rest of the question. So now we're working with 5, 10, 15, 20, and 100, because these are divisible by 5. So we need to find our constant difference. It should be 10 minus 5 is 5, 15 minus 10 is 5, 20 minus 15 is 5. So our A value is 5, our D value is 5, our N value, we don't know what our N value is, but we can calculate what our N value is. And we're going to substitute Tn, and our A value is 5, it's N minus 1 times our D, which is 5. Our Tn is equals to 5n minus 5. Therefore, you can see that our Tn, the 5 and 5 will cancel off. Therefore, Tn is equals to 5n. So we can just safely say that Tn is equals to 5n. And we need to calculate what our n is by substituting the last term, which is 100. So we go ahead, substitute 100 is equals to 5 over n. And we divide both sides by 5. Therefore, n will be equals to 20. And we're calculating the sum of 20 terms, right? And we have our last term, so we can just safely say, let's calculate the sum. We're calculating the sum of 20 terms, which would be 20 over 2. Our first term is 5, plus our last term is 100. So the sum of 20 terms, you punch everything into the calculator, it will be 20 over 2, open bracket, 5 plus 100, and you will get 1050. So what we just calculated, the sum is the sum of all the values that are divisible by 5. So really the sum of 20 equals to 1005. So we've calculated this. So now we can see that the unknown, which is the sum of all the values that are not divisible by 5, you can really find them. And you can just really find this by using our algebraic skills of making the equation subject. So what we need to do now is just say the sum, really make this whole thing subject. And how do we do that? We take this to the left hand side, right? So it means that, remember we said this is S, the sum of 96, and this is the sum of 20. So you can say sum of 96, take the sum of 20 to the left hand side, to be minus the sum of 20 will be equals to the sum of natural numbers that are not divisible by 5. So we could just really rearrange this and say sum of natural numbers that are not divisible by 5 is equals to the sum of 96 minus the sum of 20, which is equals to the sum of 96 is given by 5040 minus the sum of 20 is 1050. So therefore our answer, the sum of values that are not divisible by 5 is equals to, if you subtract the two values, 5040 minus 1050, we get 3990. And that will be the solution of sum of all the values that are not divisible by 5. So really the hallmark of this question is understanding really this formula here. And it repeats itself and it doesn't change. It just depends on what they ask you. And really that will be the end of the lesson.